Hello everybody, now we are going to start our next chapter and our next data structure, that is ArrayList. So ArrayList is a inbuilt data structure in Java, and it is a linear data structure. Like in previous chapters we studied one of the data structures, that is array, right? That is also a linear kind of data structure, and whatever the elements we are storing, that is stored in continuous fashion. So in arrays we have some limitations. Suppose let us consider that I want to store, like in my class right now, like consider that there are 5 students. So if I want to store the marks of 5 students, I will create a integer type array for 5 students, and I will store the marks for my 5 students. 1 2 3 4 5 1 2 3 yeah 4 5 5 students marks I can store in my array. Suppose in future, suppose like I got 10 students, then I can't change the size of my given array, because in arrays chapter we studied that the size of my array is constant, I can't change. So for that purpose I need to create another array of 10 size. Let us consider that in future I got like increased students like around 10%, then my students will be 20. Let us consider that I have 20 students, then again I need to like again create an array of size 20 and again refill all the information from my previous arrays. Okay, so these might sound like not a viable option in real world application. So to tackle that, we implemented or we designed ArrayList. So ArrayList is going to be like a super easy chapter. So if you are familiar with array, then this is going to be very much similar with arrays chapter, and ArrayList is also like kind of easy, you can say easy chapter. And based on ArrayList we have one important question, and we need to understand that particular question. So let us start this chapter. Now let us talk about what are the differences between arrays and ArrayList, and what is the need for ArrayList. So first of all, what I told you, that arrays are fixed size. So because of the fixed size of the array, it becomes like difficult when it comes to like real world application. Suppose let us consider that there are I already told you that 5 students, and if I want to like add another student, I can't change the size. But in ArrayList I can alter. Suppose if now I have like 5 students, in future like there are 10 students, then I can easily change the size of the array list, whereas in arrays we can't change the size. Okay, this is one of the things. And the second thing is primitive data type. So how we used to declare our array, what we write, we will write int. This is primitive data type. Okay, but when we are going to implement ArrayList, we won't write int, we write integer, because we will ArrayList is a data structure based on class. We will create the objects of my ArrayList. Okay, so for that we will import or we will like include integer class, and we will create integer ArrayList object. I hope you got my point. Okay, so int is a primitive data type, whereas integer is class. Okay, so to implement array we used to write int. If we want to like implement character array, then we used to write char, but here we will write character, right? This is the only difference. After that, if I want to like implement what we can say a boolean value, then I need to write bool here, but here I need to write all boolean class. So here I can't like directly access or directly give elements using primitive data types when it comes to ArrayList. So for ArrayList I need to give the classes in the place of primitive data type. Okay, so these are the two major differences between arrays and ArrayList. And the advantage of ArrayList, we can change the like we can alter the size, and we can fluctuate the size of the ArrayList, whereas in arrays we can't fluctuate with its size. Okay, now let us talk about like how we can implement ArrayList in our VS Code. So to implement ArrayList, first of all we need to import the Java package, Java collection frameworks, because in Java collection frameworks we have a package called as ArrayList. So for that we are importing java dot util dot, I can write ArrayList here, ArrayList, or I can write star. So star will take whatever the classes we have, everything. Stars means everything. So we can write java.util.star. After that I need to write public class, my boilerplate code basically, java basics. This is my class name. In this I need to create my main program, public static void main string args. After that here to implement ArrayList, we are creating the object of the ArrayList. ArrayList is a class which is there in my Java collection framework. So from the class we are implementing, or we are accessing all the methods, all the properties which are there in my ArrayList class by creating an object. Okay, so here I am going to create my object ArrayList. In this, let us consider that I am creating integer type ArrayList. So I need to write here integer, and my list name, let us consider that I am creating as list, is equals to new ArrayList. That's all. Here, yeah, that's all. New ArrayList. That's all. So this is how I can implement my ArrayList in Java. Okay. Now this might a little bit familiar if you are coming from C++ or C background. They are concept like vectors in C++. In Java we have a ArrayList. So in C++ vectors are kind of similar to ArrayList. Okay, so what are the advantages of vectors? We can fluctuate the size of the ArrayList. What are the advantages of vector? What are the advantages of ArrayList? That is, we can alter the size of the array. Okay, size of the given ArrayList. After that we are creating the object. So let us consider that in OOPS chapter we already studied that we will write class name, we will write class name. After that to create object we will write object name is equals to new class name. So similarly to implement the objects, after writing our class name, what we are doing, we are writing our object name. After it here new ArrayList. So this is very similar. Here we are creating the objects of my ArrayList class. Okay, now let us see what are the operations, what are the various operations, and how to add elements, delete elements, or how we can find out the size of the ArrayList. What are the various operations that are there when it comes to ArrayList? Now let us talk about that. So when it comes to the operations of ArrayList, there are various operations like add element, get element, remove element. If we want to remove the element, then we will write remove element. After that, if I want to set a particular element at a particular index, then we will write set element. After that, contain elements. So to add element in our ArrayList, we will write ArrayList name dot add. And if I want to add 1, then I will write 1. That's all. So this is how I can add elements in my ArrayList, and the time complexity for adding is big of 1, that is constant time. Okay, if I want to get the element from my ArrayList, so if I want to get the element which is present at that particular index, then what I will write name dot ArrayList name dot get. So these all are methods. So when I create the object of my ArrayList, after that I am trying to access the methods which are there in my class ArrayList. Okay, here name dot get. In this I need to pass the index, and we will get the element which is present at that particular index. After that, suppose if I want to delete a particular element or remove a particular element in my ArrayList, then I need to write name dot remove index. That's all. So let us consider that 1 2 3 4. ArrayList is very similar to arrays, so you can visualize it in terms of arrays. Okay, so let us consider that I want to delete 3. So what the class or the function which is there in my class will do, it will come at each array and it will look at the particular given element. Here I need to pass not the index, I need to pass the element. Okay, so here suppose let us consider that I want to delete this particular element at that particular index 0 1 2. So at second index I will remove this. So this is how removal of a particular element works. Now let us talk about if I want to set a particular element at a particular position. Now if I want to like set 9 at first position, that is first index, then what I will do, I will write name dot set. First of all I will write index, in which index I want to insert, after it my element, which element I want to insert, right? After it, if I want to like check whether that particular element in my, suppose here let us consider that this is my array list 1 2 3, and if I want to check whether 9 lies in my array list or not, for that what I will do, name dot contain, and in this I will give my element. If this particular element is present in my array list, then it will give me true, else it will give me false. So this is all the operations, and there is one more, that if I want to add a particular element at a particular index, then what I will do, I will write name dot add, I will write index name, after it I will write element. So this thing will also give me big of n time, right? That's all. So these are the various operations. How many operations? 1 2 3 4 5 and 6. So these are the 6 different operations which are there in our linked list, and these are very easy. First of all, now let us code this thing. So in the main program, suppose I want to add list dot add integer, I want to add 1. After that I want to add list dot add 2. After that list dot add 3. After that list dot add 4. Suppose if I want to print the elements which are there in my linked list, then I will just print system.out.print and I will write list. That's all. Now let me save and run. So if I run this code, what it will show? 1 2 3 4. It is showing public class, okay, it is showing some kind of error, that is I need to give Java basics, not basis. Yeah, basics. Now let me save and run. Yeah, you can see that I got my array list. So this is my array list. Suppose if I want to like delete elements from my array list, then I will write element name dot get. Suppose if I want to like get the element which is there at my 0th index, then I will write list dot get. So this thing will give me 1, probably 1. Yeah, we need to print it, right? So we need to print system.out.print list dot get 0th index. So I am printing the element which is present at the 0th index, that is 1. Now let me save and run. Yeah, suppose if I want to remove element at a particular index, suppose I want to remove list dot remove. If I want to remove at first index element, that is 2, and after that I am printing system.out.print list. So you can see that. Let me run this code. Yeah, first of all save. Yeah, let me run. You can see that we got the output 1 2 3 4. After that we are printing the element which is there at the first index. After that here I am deleting 2 value, right? This is how we'll do like deletion from my array list. Okay, now let us talk about like how we can check whether the element contains or not. So for that I am printing list dot contain, and I am passing here 100, or I am passing 1000. So we already know that this particular element is not present. So if I run this, then it will show me false. So you can see that first of all I am printing my array. After that I am printing the 0th element, 0th indexed element. After that I am deleting 2, and finally I am searching for 1000 in my array list. If it is not present, then it will show me like false. Okay, so to get the size of the array list, here we will use a dot size operator. So this thing will give me the size of my array list, right? In arrays chapter, what we used to do, will write array arr dot length. Here what I will write, suppose if my array list name is arr, then I will write arr dot size. So you can see one thing here, that this is my attribute. So in OOPS chapter we used to access attributes like this. So this is my property or attribute, and this is my function, right? So in arrays, what we used to do, we used to get the length of the array using attributes. Here we will use functions. Now let us see how we can get the size of the array list by coding it. Here first of all I am passing list dot add 1, after that list dot add 2, that's all. After that I am printing system dot out dot print list dot size, that's all. Now let me save and run. So you can see that the size of the array is 2. Here I am adding 2 elements, so my size of the array is 2. And suppose let us consider that I am passing another element here, that is list dot add 100. So if I pass 100 here, then you can see that the number of elements are 3. So my size will be 3. So this is how we will get the size of the array list, and we did all the operation. Now let us do some basic questions related to array list. So in the given question we need to reverse the elements first of all. What are the steps here? First of all we will add the elements first of all we will add elements in my array list. After adding we need to reverse the elements which are present in my array list. After reversing, what we need to do, we need to print my array list. Simple. So second step will be printing my array list in the reverse order, that's all. Print. So this is the thing we need to do. So what is the pseudocode here? The pseudocode will be very simple. After creating, we already know that how to add elements in my array list. So after creating my array list, I will run my loop for int I is equals to al dot size minus 1. After that I should be greater than or equals to 0. After that I minus, in this I will print system dot out dot print al dot get at ith index element, that's all. So this is how I am going to print the reverse of my array list. Okay, now let us do code this question. So in the main program I am going to create my array list and integer type array list. Integer is equals to new array list, that's all. After creating my array list, it is showing some kind of error, that is array list can't be resolved to variable. Okay, array list we need to give the name also, right? So I am giving name as al. My array list name is al. Okay, after that here I need to add the elements in my array list. Let us consider it add 1. I am adding 1. After that al dot add 2. After that al dot add 3. After that al dot add 4. After that al dot add 5. Okay, I am adding 5 elements to my array list. Now I need to print my array in reverse order, that's all. So I need to change for int I is equals to al dot size minus 1, because the index starts from 0th index, right? So size minus 1. After that I should be greater than or equals to 0. After that I minus. In this what I am going to print, I am going to print al dot get ith element, that's all. So here you can see that first of all I am adding elements into my array list. After that I am running a loop. In the loop I am getting the elements which are there present at that particular index, that's all. These are all the things I am doing. So this is my reversing step, printing, that's all. Now let me save and run. So if I run this code, then I should get my numbers in reverse order, that's all. Now let me see. You can see that I got my numbers as 5 4 3 2 1, that is in my reverse order, that's all. So in this question we need to print the maximum element which is present in my array list. Okay, so here in the given array list, what is the maximum element? 9 is my maximum element. So we already know that we will just run a loop and we'll consider that our maximum is equals to minus infinity. After that we will run a loop for our whole array or array list for int I is equals to 0 and I should be let us consider that least is my name, so least dot size, after that I plus plus. In this what we'll do if max is less than my al dot get ith index. If this is the case, then what we'll do, we'll change the value of max is equals to al dot get I. That's all. And finally we will print system dot out dot print our max value. So this is going to be like very similar to arrays chapter, right? So whatever the questions you are doing in arrays or whatever the questions you are doing in ArrayList, you can do the same questions using arrays. Okay, so whatever the questions you are doing using ArrayList, you can do the same using arrays also. But the only thing is when you are like in competitive coding, in like hardcore competitive coding, in that particular scenarios, using ArrayList can be like a little bit beneficial for you. Okay, because we can change the size, we can manipulate the things in whatever way we want, but when it comes to arrays, we can't manipulate the things that much. That's why using ArrayList is very much recommended when we are in competitive coding field. Okay, now let us code this thing. So I'm going to create my ArrayList, ArrayList, integer type ArrayList, integer type, ArrayList name is least is equals to new ArrayList. That's all. After that here I can remove integer also, no need. After that here, first of all I need to add elements to my list, that is list dot add. I'm adding 0. After that list dot add 9. After that list dot add 1, list dot add -1. That's all. After that here I am creating my max function, int max is equals to integer dot minimum value, that is minus infinity, right? So integer dot minimum value. After that I am running my loop. So for int I is equals to 0 and I should be less than least dot size, after that I plus plus. In this what I am doing, I am comparing, that is if max is less than least dot get at ith index. If this particular condition is true, then what we need to do, we need to change the value of max. That's all. So here I need to change max is equals to least dot get ith index. That's all. And finally after running loop, simply print system dot out dot print max value. That's all. Now let me save, and you can see that in the given list, what is the maximum value? 9 is the maximum value. So if I run this, then I should get my answer as 9. So let me save and run. You can see that we got the output as 9. So this is how we will like calculate the maximum value in the array list using ArrayList. Okay, so in the given question we need to swap the elements which is present in my array list. So this is the 0th index, first index, second index, third index, fourth index, right? We need to change the elements which are present at the 0th index and the third index. We need to swap. So after swapping, my array will be 2, 3, 9, 5, 6. So this will be the output I will get. So how we can swap? By creating a temporary variable. So we will create int temp is equals to al. Let us consider that al is my array list object name. So al dot get first index. After that al dot get first index is equals to al dot get 3. That's all. After that al dot get 3 is equals to temporary. So these are the 3 steps to swap any 2 numbers in my array list. That's all. So let me create my array list. Array list of integers, integer al is equals to new array list. After that, after creating my new array list, what I'm going to do, al dot add 1 after that al dot add 2, after that al dot add 3. So if I want to like swap the position of 1 and 3, then what I will do, I will create my temporary variable int temp is equals to first of all, before swapping, let me print my array list, that is al. After that I am going to create a swapping, so int temp is equals to al dot get element at 0th index, because I want to change the values of 1 and 3. Okay, after that al dot set al dot set at the 0th index I need to like set element, the third element, that is 3, right? So al dot get index, I need to pass its index. What is the index? 1 2 3, that is 0 1 2 2, right? After that al dot here I need to like set at second index, what I need to set? Temp variable, that's all. Now let me save, and after like swapping I need to print system.out.print my array list, that's all. Now let me save this thing and run. Here it is showing some kind of error, expected, yeah, statement terminator, delete and save and run. So you can see that before swapping we have elements 1 2 3, after swapping we got elements as 2 3 1. So here we need to save like this. After that, here in the place of al dot set at 0th index, we are setting like element, right? We are setting second index element, so al dot get at element which is at second index. After that al dot set at second index, we need to what value we are going to store? We are going to store temp, that's all. So this is how swapping will take place, not these 2 steps but these 1 2 3 steps. So this is how swapping will take place. Now let us talk about how we can like sort elements in the given array list. So here we can apply the bubble sort, say we can apply bubble sort for sorting elements. Okay, so I am applying bubble sort here for int turn is equals to 0 and turn goes up to n minus 1, right? What is n here? N is the size. After that, what I will do, we already know that bubble sort will increment I. After that, in the inner loop for int j is equals to 0 and j should be less than n minus 1 minus t. After that j plus plus. In this, what we used to do, we used to swap. So we will write these steps inside our like bubble sort algorithm. So we will write int temp is equals to arr dot get ith element, that is jth element here, because we are using iterator j. After that arr dot set at jth position, what we used to set? We used to set arr of j plus 1. After that arr dot set at position j plus 1 position, what we used to set? We used to set temporary variable. So this is how swapping will take place in when it comes to array list, and this is how we will apply bubble sort in the given array list. So if the array list is like 2 5 9 3 6, then the output will be 2 3 5 6 9. So this is a sorted array in increasing fashion, and this is how we will apply bubble sort in the given to the given array list. Now let us apply bubble sort here. Here I am creating a function for array list bubble sort. In this, first of all, I am passing public static void type function, because I am not like changing anything in my function. I am not returning anything. After that bubble sort. In this, what I am passing? I am passing a array list of integers. That is, let us consider al is my array list. Okay, here I need to give capital L. So by convention in Java, most of the like classes and all those kind of things, we give name as capital. You can see that we have given capital letter for string, capital letter for array list, and all those kind of things. By convention, the classes names start with capital letter in Java. Okay, so here array list of integer let me give AL as my array list name. In this, first of all, we need to calculate the size of the array list. So to calculate the size, n is equals to AL dot size. That's all. After that, I am going to run my loop for int I is equals to 0 and I should be less than n minus 1. After that, I plus plus. In this, what I am going to do, I am going to run my inner loop int j is equals to 0 and j should be less than n minus 1 minus I. After that, j plus plus. In this, what we need to do, we need to swap. We need to swap AL at j and AL at j plus 1 at j plus 1. So we need to swap these two indexes positions if my given array at that particular position is greater than my next element. Okay, so what is the logic here for bubble sort? The largest element will go to towards the last. So if AL dot get at jth index is greater than AL dot get at j plus 1 index, if this condition is true, then what we will do, we will swap here. So for swapping, I am going to create a temporary variable temp is equals to arr dot get element at j. After that, here AL write, not arr, AL dot get element at jth position. After that, AL dot set j plus 1 j at jth index, set arr AL dot get j plus 1. So whatever the element present at the j plus 1 index, I am going to set that element at jth index. Okay, so after that, AL dot set at j plus 1 index j plus 1 comma AL dot get, or you can write here temporary, because we have already stored that here arr of temp is equals to AL dot get. That's all. After doing bubble sort, we need to print the elements. So for printing, I am running a loop int I is equals to 0 and I should be less than n. After that, I plus plus. In this, what I am going to do, I am going to print system dot out dot print AL dot get element at ith index. That's all. Let me save here, and here in the next instead of printing next line, I will print in the same line but give a blank space. That's all. Now let me save. In this, I am creating an array list in the main program, array list of integer AL is equals to new array list. That's all. After that, I am adding AL dot add suppose 0. After that, AL dot add minus 1, AL dot add 2. After that, AL dot add minus 2. That's all. Now let me call my function for bubble sort. In this, I am passing my array list. That's all. Now let me save and run. So you can see that we got the output, that is the sorted array. Here I am passing 0, minus 1, 2, 2. So the array in the sorted array list in the sorted fashion is minus 2, minus 1, 0, 2. So this is how we will apply different sorting techniques for my given array list. Now there is an inbuilt technique for inbuilt in array list, we have inbuilt sorting function, right? Similarly, we will have the same method to sort or to use inbuilt function. Let us see what is the method we will use. Suppose let us take that we have array list, that is AL is equals to 2, 0, minus 1, minus 2. Okay, so if we want to sort this particular element without any applying sorting technique and with using inbuilt functions, then we will write collections dot sort and we will write just AL. That's all. So this method will sort the given array and the output will be minus 2, minus 1, 0, 2. So this is how the sorting will work for a given array list. So we will write collections dot sort, and in the parenthesis we'll write the array list name. That's also by writing the array list name we can sort the given elements using inbuilt functions. So collections is a function. Collection is a function, is a class in which we can first of all we'll write collection. After it, dot sort. Dot sort is a method in the Java collection framework. So by writing collection dot sort, we'll invoke the function which is there in the collection class. So whatever the methods, whatever the things going on, logical operations, we don't need to focus on that particular thing in clear. But if you are in a coding contest and all those kind of things, you can use this method to sort a given array list. Okay, now let us see how we can apply this in our code. So here this is my array list. So instead of calling my bubble sort, I am calling my collection framework, that is collections, capital C actually, collections dot sort. In this I am passing my array list, that's all. Now after passing my collections dot sort, I am going to print my array list. Now let me save and run. Let us see what the output will get. So you can see that we got the output as -2 -1 0 2. So this is a array list in sorted fashion. So by just writing collection dot sort, so these function or this method will sort our given array list. So this is a this will take around, so method will take us around big of n log n time, whereas this method bubble sort and all those general sorting techniques will take around n square time, n square. So this is the advantage. The efficiency is good, and we just need to write only one line instead of writing like 10-20 lines. So by just writing this single line, we can sort the given array list. Okay, now let us talk about how we can implement the given array list and what are the things that are going in the background of Java collection framework. So the implementation of array list is very similar to arrays. So when we implement array in Java, the memory for each element has formed in continuous order, right? Similarly, when we implement array list in Java, it is kind of similar to arrays. So when we implement, when we are writing array list integer and AL, let us consider that AL is the name, new array list. So when we write this syntax will automatically form a array in the memory. So in the memory array is formed, and that particular array depending on our compiler will create array of n size or whatever. Let us consider that n is equals to 10. So our compiler will create 10 size array in the JDK or in the compiler. After that, if we started to fill the elements inside our array, suppose the size of the array is now 10. Okay, suppose if we started to fill the elements, let us consider that I am filling my element depending on our Java version. There are different versions of Java, Java 7, Java 8. So depending, but most of the cases when we are filling the elements in the array, let us consider here the size of the array list is 10. Okay, now when we start to fill the elements in the array, when the given array which is created in the memory is filled half, then what the compiler or the JDK will do, JDK will create another array. JDK will create another array, and this array will point, this array list will start to point this array now. Okay, so this particular array list will create another array if the particular given n size array is half filled. So if this half filled array is that is the given array is half filled, then this class or this array list will create a new array of double size. So we'll create a size of 20, right? So we'll create a size of 20 and we'll copy all the elements which is there in my previous array, that is 1, 2, 3, 4, 5. And if the given array, new created array is also half filled, then we'll create another array of size 40. And similarly, if the array is again half filled, then we'll create a new array 80. After 160. So we'll create new array when the given array which is created in the compiler is half filled. Okay, so this is how the implementation of ArrayList works. Now let us talk about multi-dimensional array list. So in previous unit arrays, we already seen 2D arrays, multi-dimensional arrays, ND arrays, 3D arrays, and all those kind of things, right? And we already did a lot of problems related to arrays. So whatever the problems we did using arrays, we can do those same problems using array list also. So here, how we can define like arrays, 2D arrays, right? We will write int ARR and two square brackets. So this is how we used to like declare a two-dimensional array. So similarly, to declare a two-dimensional or n-dimensional array list, we will write first of all array list, and in this we will write again, if you want to like declare a two-dimensional array, we will write array list again, array list, and which data type or which class we want to implement. Suppose if you want to implement integer type array list, then we will write integer is equals to new array list. That's all. So this is how we will implement a 2D array. Suppose if I want to like implement a 3D array, then I will write array list. After it, in this array list, and again inside it array list, right? So this is how. And suppose if I want to like store float value, then I will write float, or suppose if I want to like store boolean value, then I will implement boolean class is equals to new array list. That's all. So this will implement my 3D array, and this is how we will implement my 2D array. Suppose let us consider that that I am creating a array, 2D array. So here I will write the name as main list. So main list, what main list will store? Main list will store main list in the memory allocation. This is how like memory is allocated for my like given array. So main list will store these two. Let us consider that I am storing list 1, list 2 and list 3 values in my main list. Okay, so this will store list 1, after list 2, after list 3. So list 1, list 2, list 3 will point to the integer values, and main list will store the array list of the like you can see that you can consider that here main list is equals to is a universal set, and L1, that is list 1, list 2 and list 3 are the subsets of my main list. Like you can imagine like this also, right? Similarly, list 1 will point to the given arrays 1, 2, 3, 4, 5, and this is a multiplication of one table, and this is a multiplication of 2 table up to 5, and this is multiplication of 3 table basically. Okay, so this will point to 2, 4, 2, 4, 6, 8, 10, and this will point to 3, 9, 3, 6, 9, 12, 15, right? So this is how like storing or the pointing or reference of, first of all, these main list will reference to this, or you can say that these main list will point to these 3 subsets or sub-array list, and these sub-array list will point to the objects or integer values to my these sub-array list will store the values of my integers. So this is how the creation of 2D array or 3D array list works in Java. Now let us code this thing and see. Let us now I am creating a 2D array, array list of integer is equals to a name of the my array list is main list is equals to new array list. That's all. After that, here what I am doing, I am creating a part sub array list of my main list. So for that, what I can write, I will write array list of integer. Let us consider list 1 is equals to new array list. So here you can array list. After it, I want to add in my list 1. In my list 1, I want to add 1. After list dot add 2. After list dot add 3. So I am adding 3 elements. After to add my list one in my main list, how I can do this? I can write main list dot add and I can write list one. That's all. So this is how I can add elements or sublist to my main list. Okay. After that, here let us consider that I am again creating another list sublist as a integer list2 is equals to new array list, right? That's all. After that, here I can add elements to my list2, that is list2 dot add list2 dot add. Suppose I am adding 2. After that, list2 dot add 4, list2 dot add let us consider I am adding 6. That's all. Now if I want to like print here, I need to give list. Okay, so suppose if I want to print the main list, then I will just write system.out.print main list. That's all. Now let me save and run. So you can see that here it is just printing 1 2 3, and in this I need to add list2 to my main list, right? So I will add main list dot add list2. That's all. Now let me save and run. So you can see that we got the elements as 1 2 3 and 2 4 6. So this is how we will create a two-dimensional array list. Suppose if I want to like print the elements using a loop, then how I can do this? I can do like instead of printing the actual element, I can print for int I is equals to 0 and I should be less than main list dot size. After that, I plus plus. In this, what I can do, first of all, I need to store the given list sublist. Okay, so for that I am creating a new array list of integer current is equals to new array list. After that, I am running my inner loop for int j is equals to 0 and j should be less than current list dot size. After that, j plus plus. In this, I am printing system.out.print. Let me remove ln. After crr dot get I at jth index plus a blank space. After that, after completing my inner loop, a next line. That's all. Now let me save and run. Here I need to store the value of main list here. I need to store the value of main list here. That's all. Main list dot get ith element. That's all. Now let me save and run. Here I need to give a statement terminator. You can see that we got our output as 1 2 3 2 4 6. So this is how we can print the elements using a single statement, that is system.out.print main list, or we can run a loop and we can print the elements which are there in my two-dimensional array list. So this is how we will create a two-dimensional array list. How we can create? First of all, we will write array list in the like angular brackets array list. After that, we need to write the class name, that is integer, boolean, float, and all those kind of things is equals to my array list name is equals to new array list. So this is how we will create a new two-dimensional array list in my given like Java, right? In Java. Now we are going to do an important question, that is container with most water. So you can do this same question using arrays also. Generally, most of the coders will do this question with using arrays. We are doing it using array list. Okay, so there is no like that much change when it comes to arrays and array list. We can do whatever the questions we are doing back there using arrays, we can do those same questions using array list also. There is like not that kind of like huge difference between two. Okay, so in this question, the user will give us n lines. Which are perpendicular to x-axis, and we are going to use 2 lines to form a container, and we need to tell the user that holds the maximum water. So you can imagine that some water will fall onto this container, and we need to tell that in which container the most water will get trapped, or in which container will hold the most water. We need to tell the container and the area of the water. Okay, you can see that this is a line, and this line having one height. After the next line is 8, after the next line is 6, 2, 5, 4, 8, 3, 7. So these are the heights of the given lines, and each line, so by combining two lines, the two given lines, we can form a container. So each two lines will form a container and hold some water, and we need to tell in which container the maximum water will get stored. Okay, so here you can see that the line 1 and line 7 will hold some water, in between it. Okay, right, will hold some water, but this water is less than the maximum water, and the maximum water is shown here, that is the height is 7, and the indexes is total elements are 0, 1, 2, 3, 4, 5, 6, 7, 8. So 8, that is 9. 9 minus 1. So 9 minus 1 will give 6. So 7 6 ja, here 8 minus 1, that is the indexes, that is 8 minus 1. So the width is 7, and height is 7. So the maximum water which will get stored here is area of water in which the container will store the maximum water is equals to height into width. So you can see that each container will form, so two lines will form a container. So you can see that 1 and 8 will form a container, 1 and 6 will form a container, 1 and 2 will form a container. Similarly 1 and 5 will form a container, 1 and 4, 1 and 8, 1 and 3, 1 and 7. So two consecutive containers will form a container. Okay, two consecutive lines will form a container, and we need to tell the maximum area in which the container will store. So we need to choose those lines which will store the maximum area. Okay, here you can see that area is equals to height into width. So to get maximum area, can you observe one thing, that if my height is like maximum and if my width is maximum, then I will get my maximum area. So how we can get maximum height or maximum width? So by calculating the maximum height and the maximum width, we will get the container which stores the maximum water. Okay, that is nothing but our area. So to get the maximum area, we need to choose the height which is maximum, and we need to choose width which is maximum. So by choosing these two things maximum, by multiplying this, we will get areas maximum. So this is the basic concept of the question. Now let us see how we can approach this particular question using logical method. We will first of all choose brute force, and by brute force we will try to optimize our solution. So coming to the brute force, so we'll start doing this question using first of all our logical approach. So what logical approach will tell us? The logical approach will tell us, first of all, I am going to create 2 pointers or 2 iterators, whatever you want to say, 2 pointers or 2 iterators. Here I am going to choose a first iterator. Let us consider that this is my first iterator, and I am going to change the pen for my second iteration. Yeah, let us consider that this is my second iterator. Okay, first of all I will calculate the area between these two. Right, after calculating I will store. Let us consider that I am storing the area. So I will store in the given array. After that I will calculate the area or the container area between these 2 pointers. After that I will calculate for this. After that similarly for this. After that for this, like this I will calculate the area between these 2 pointers. Right, similarly these things goes on, this thing will go on, and after calculating all the iterator up to the end, I will change my initial iterator and I will do my next iterator like this, and with this like this, the iterative approach will go on. Let me write the pseudocode here. So what I will do, first of all, I will create a function public static store water function. In this I will pass my array list. That's all. I will pass my array list. So initially I will create a variable that will store the maximum water. So max water is equals to 0. After that, my brute force approach. In the brute force approach, what I will do? I will run a loop for int I is equals to 0 up to I should be less than my size of the array list. After that, in this, what I will do? I will run a inner loop for my next iterator. So for my next iterator, you can see that when I is equals to 0, my next iterator is 1. That is j is equals to I plus 1. Okay. After that, the same thing will go up to size of my array list. In this, what I am going to do? I am going to take my height. So can you observe one thing, that my height here, let us consider this is 1 and this is 8, right? So here, what is the height of the water? 1. So if I take two lines, then the height will be minimum of those two lines. So the minimum of these two lines will become my height. So can I write that my height is equals to math dot minimum of the ith element, that is I comma j. So whatever the elements which are present ith index and jth index, the minimum between two will give me height of the array, height of that particular container. After that, I need to calculate width. So width is equals to j minus I. That's all. So here you can see that j is 1 and I is equals to 0. So the width will become 1 here. Okay. So this is how I will calculate my width. After that, I need to calculate my water which is trapped in my current container. So this is my current container. So I will calculate current water trapped is equals to height into width. Okay, height into width. After calculating my height into width, I will take maximum water. So my max water will change into max dot max water comma current water. So if the current water is big or huge or large than my max water, then I will change my max water value. That's all. And finally, after running my loop, I will print system.out.print my max water. That's all. So you can see that in the example, we will get max water as 49. Now let us code this thing and understand how the code actually works. Here I am creating a function, public static int type function. In this I am passing the function name is container max container. In this I am passing my array list of height. So array list of integer, and the name of the array list is height. In this, initially I am storing max water is equals to 0. After that, my brute force approach. So my brute force approach, what it will say? First of all, I am going to run my outer loop. So for int I is equals to 0 and I should be less than height dot size. After I plus plus. In this, I am going to run my inner loop for int j is equals to I plus 1. And j should be less than height dot size after j plus plus. In this, I am going to calculate my height and the width for my given two lines. So int height is equals to math dot minimum value of height dot get the element which is present at the ith index, and height dot get element present at my jth index. So the minimum of these two will give me the height. After it, I need to calculate the width. Width is nothing but width is equals to j minus I. That's all. J minus I. After that, I need to calculate my current water is equals to width into height. That's all. After that, what I'm going to do here, I'm going to like change the value of max water if my current water is greater than my max water, is equals to math dot max of current water and max water. That's all. After running my loop, I am going to return max water. That's all. Now here I am going to create a new array list of integer height is equals to new array list. A new array list. That's all. After that, I am going to add the elements. That is height dot add 8. Similarly, copy this same thing and paste again. So here I am going to give 6. The example which we have taken, I am giving here 2, 5, 4, 8 and 7. That's all. Now let me save, and here I am calling my function, whatever the value returned by the function, that is max container. I am passing height here and I am printing the value. Right now let me save and run. So here it is showing some kind of error, that is symbol can't be found. Here I need to give WD, not WT. Okay, now let me save and run. So you can see that we got the output as 49, and we already did the dry run for this particular code, and what we got, the output for maximum water that contained between 2 lines is 49. So this is how the code, this is the code for calculating the maximum water that got trapped between the given 2 lines. So the time complexity for this code, the time complexity will be, time complexity is equals to big of n square, because we are running 2 loops. So the time complexity will be big of n square, and this is not like that kind of like efficient code. So let us try to optimize this particular code using approach called as 2-pointer approach. Now let us try to optimize the same question that we did using approach called as 2-pointer approach. So in this, what's this approach tells that you need to understand one thing here, that we are using 2 pointers, or you can say that 2 iterators. So this iterator will like this iterator will point to current line. So in the brute force approach, how we did, next iterator will point to next line. Instead of like pointing to the next line, here let us consider that this is my left pointer and this is my right pointer. So we'll build 2 pointers, or you can say that simply 2 iterators, because we don't have a concept of pointerators in Java. Okay, so we'll build 2 iterators, left pointer and right pointer, and we'll calculate the area between these two. And there's only one condition you need to understand here, that is my left pointer is less than my right pointer, then what we'll do, we'll just run, we'll do left plus plus. Else we'll do, that is my right pointer is less than my current pointer, then we'll do right pointer minus minus. That's all. This is the only thing. And by like moving this pointer, we'll calculate the container water, and we will move this pointer, and this pointer iteration will continue until we hit a base case. And this is the base case, or this is the condition here, that if my left pointer is equals to right pointer, then what we'll do, we'll stop our loop. So we'll run only one loop, and using that loop we'll like calculate the area of the like maximum water that got contained between 2 lines. Okay, in the previous approach, what we used to do with a consecutive pointers, but here in the efficient optimized code, what we are doing, we are creating a left pointer and a right pointer, and we are calculating the water trapped between these two, and after that we are changing the values, and these change of values will continue. And you need to observe one thing here, that let us consider that this is my water and this is my lines. Okay, so suppose if I want to calculate the maximum water that got trapped between these two lines, then you need to observe one thing, that the height will be my lowest of this. So my height will be this and my width will be this. So let us consider h1 and h2. So if h1 is greater than h2, then my height will become height is equals to h2. So this is the thing you need to observe, and these are the conditions you need to remember when we are going to do these question with the left pointer and right pointer approach, that is two pointer approach. Now let us code this thing. So here I am going to create another function for my optimized code. So here I am going to create my public static int type function, because I am going to return the total value right after optimized container, or you can say that two pointer. In this I am just passing my array list of integer height, height, height. In this, first of all, I am creating int max water is equals to 0. After that, the right pointer is equals to height dot size minus 1, that is the last element, right, minus 1. After that, my left pointer, int left pointer is equals to 0. After that, I am running my while loop, because I am changing the left pointer and right pointer and calculating the area, right. So while my left pointer is less than my right pointer, so this loop will continue until these two values become same. Okay, after that, here I need to calculate water, I need to calculate height, So for calculating water, I need to calculate height. ht is equals to math. The code is kind of similar to the brute force approach, but here we are using only one loop, that is the only case. In the previous code, in the brute force approach, we are how many loops we are using? We are using 2 loops, but here we are using only one loop, so that thing will give us big of n time complexity. Okay, so here math.max of height.get left pointer, comma height.get right pointer. After that, int width is equals to right pointer minus left pointer. After that, max water is equals to math.max of my max water, comma my current water. So I need to here create my current water here. Here. So int current water is equals to width into height. That's all. And here I need to place current water. So the maximum between my current water and maximum water, that thing will be assigned to my max water, right? After that, here I need to give my if statement. If height dot get of my left pointer is less than height dot get of my right pointer, height dot get of my right pointer. If this condition is true, then what I'm going to do? I'm going to increment the value of left pointer. I'm going to decrement the value of my right pointer minus. That's all. Now let me save, and this step is known as updation for pointers. That's all. Now this thing will be running. This thing will run on here. It is showing some kind of error, but whatever. ArrayList, yeah. So here I am calling, instead of calling my max pointer, I am calling my two pointer. That's all. Now let me save, and it is showing some kind of error, that is return type. Yeah, we need to give return type. So here we need to give return, and we are returning maximum water. That's all. Now let me save and run. So by running this same code, we'll get the same output. That is, it is showing some kind of error, that is two pointer. Yeah, we can't give like the name with a number, right? So two pointer. Here I am writing two pointer. That's all. Now let me save and run. So you can see that we got the same output using this also. So the only change here is this thing. The code will give me big of n time complexity. So the time complexity for this thing is time complexity is equals to big of n. whereas the time complexity for this thing is big of n square. So brute force approach will give me big of n square, and we tried to optimize the given code using 2 pointers approach. So this is how the question, this is how we can do the question of contained water. So what is the difference between the contained water and trapping water? So the only difference between the contained water and the trapping water is, in trapping water we used to calculate all the water that got trapped between two bars or two like buildings, whatever we can say, two lines. So here we are going to calculate all the water here, like let us consider x, y, z. So here we will calculate the sum. So we will calculate total water that got trapped. Okay, here in the trapping water we will calculate the total water, that is x plus y plus z. So this thing will give me the total water. Whereas in this question, when it comes to container with most water, you are only choosing that only container that holds the maximum water. Let us consider that these container will store maximum store water x, and these container will store maximum water y. So we'll print y, we don't print x because that is not maximum water, that doesn't hold maximum water. That's why we'll print y as my like output. So here we are only printing maximum water, and here we are printing the total water. That's all. So this is the only difference between trapping water and container with most water. And if you are like familiar with trapping water question, then this question is kind of easy for us. Okay, I hope you got the logic, you got the brute force approach and 2 pointers approach and all those pseudo codes and the like logical things we did. Up to now we have talked about the operations, how we can implement array list, and different simple questions and one important question. So up to now we covered like important topics related to array list. So with that being said, we have completed our chapter, that is array list, and I want you guys to do the like assignment on your own. Up to now we have completed up to around 20 chapters, and now we are going to see one of the like important data structures which is very important when it comes to placements, that is linked list. Okay, with that being said, I will see you in the next chapter.